everyone. Welcome to today's class. Today we'll start to talk about data visualization. We will use about 2.5 lectures to talk about this topic. And the first session is about the underlying theories about data visualization, sort of somehow new theories about it. And then in the next few lectures, we will talk about, in particular, a package called ggplot2. And we will use ggplot2 to create different types of visualizations for different types of data and different combinations of data types. Okay, all right, let's start from the very beginning. So we are done with introduction to data science and our basics. So we are here, data visualization. The first session is about composing and dissecting data graphics. So there is a taxonomy for data graphics. There are 4 basic elements: visual cues, coordinate system, scale, and context. And Hadley Wickham, who is the author of ggplot2, the ggplot2 package, implemented these 4 elements when he created the package. We will see in a moment. So let's take a look at each component or each element in a graphical display one by one. So first, visual cues. So this plot shows you a big picture of different visual cues: position, length, angle, direction, shapes, area, volume, color saturation, and color hue. And definitely they are used to visualize different types of data and different number of variables as well. So for example, length can be used to measure one-dimensional quantitative data, and area can be used to measure two-dimensional quantitative variables, and volume three-dimensional. So these are all about magnitudes, right? And angle is similar to length, right? But it can be used to demonstrate numeric variables too, but it is in a different coordinate system, a polar system. And then there are some visual cues that can be used to illustrate relationships between variables. For example, position and direction can be used to show relationships between 2 variables. And some variables can be used to illustrate, to display numeric variables and categorical variables. For example, color saturation, right? You can use it to show continuous numeric variables. Sometimes you can also use it to show categorical variables. Okay? And lastly, shapes and color hues are usually used to display categorical variables. Okay? So the purpose is to make contrast between categories, right? So let's take a look at them one by one. So first, length. So length is used to show one-dimensional quantitative variables. But just pay attention, sometimes people can mislead you using very smart tricks. For example, so this graphical, the first plot shows you, so this is a bar plot. Now in January 2013, you have the some percentages shown. So first one is 35%, the second one is about 40%. But notice that in the first plot, the y-axis starts at 34%. And consequently, you see it exaggerated the difference between the two bars, like the height of the two bars. If you start the y-axis at 0%, then you see the difference is much smaller, right? Much smaller. So sometimes you can mislead people, but as a professional data scientist, we should never do that. Okay? We should be honest and um, try to show the data in its original way. Angles can also be used to show one-dimensional numeric variables. So, for example, in a pie chart, we use angle to show the size of each category, okay? Each the percentage somehow like that. Okay, so this is like 25%, 50%, etc. Donut plots are similar to pie charts. Instead of using angles, it uses arcs to show the magnitude. But essentially, because the arcs are related to the angle, the size of the angles, directly related to the angles. So essentially, they are the same thing. They are using the angles to show the magnitude. Okay. And next, two-dimensional area. Three-dimensional numeric data, you can use volume. Okay. However, you see that just compare these two. Okay. So the first square is representing a unique square. Right? So the magnitude is 1. Then the second is 2 by 2, 2 times 2. So it represents 4. Okay. And similarly, at the bottom, the first one is a unit cube. Right? The second one is a cube that represents 4 times of the previous cube. The volume is 4 times of the previous one. Right? So you can tell very obviously the difference between these two is more obvious than the difference between these two cubes. Right? And if you compare length of two segments that represent 1 and 4, so you see the difference is even bigger. Right? So from these three examples, it's very obvious that one-dimensional measurement like length is the most effective. The three-dimensional one is the least effective. So whenever it's possible, just directly use length instead of using area or volume to show one-dimensional data or quantitative variables. And then the next visual cue is position. Position is used to show relationships between two quantitative variables, usually quantitative. Sometimes you can show the relationship between one quantitative and one qualitative. Okay, it's very rare. For example, in a scatter plot, we can use position to show the trend, the relationship. So the first one is apparently a linear relationship, positive. And the second one is a negative linear relationship. You can also use positions to show clustering within observations relationship, like cluster 1, 2, and 3, right? And you can also identify outliers. Outliers are observations that are far away from most of the data points. Right? So obviously this is an outlier. Okay? So position is used to show relationship. Okay? And next one is direction. So sometimes you want to create a line plot somehow to show the trend. Usually it is using a time series plot. Right? So for example, in this plot, you can see a clear upward trend from 1960 to 2000. direction. And then shape. Shapes are used to display categorical variables usually. Okay, we use different shapes to demonstrate different categories. For example, square, circle, triangle. Okay. And next group is shade and color. Okay. Color saturation is the shade, and color hue is also called color itself. Okay. So colors are very flexible. You can use colors to display categorical variables. Sometimes you can also use colors to display numeric variables, quantitative variables. For example, in this graphical display, uh, it shows estimated fraction of precipitation lost to some reason from 1971 to 2000. So each unit is probably a county. And the author used, I think it is a rainbow color palette to show a numerical variable, which is fraction of precipitation loss. Okay. So from this plot, you see that it probably is not a good idea because you see 0 to 0.09 is white, and then goes to pink, dark pink, and purple, and aqua blue and blue, etc. So there is no pattern. Okay, so it's kind of like at least from the lightest to the darkest, there's no such kind of pattern in between the colors. So choosing the rainbow palette is not a good idea in this case. Okay? So actually, maybe choosing one color and using different shades or color saturations of the same color to demonstrate this numerical variable is a better idea. Okay? So that you can clearly see the change and the relative relationship between counties, among counties. So we need to be careful. And there are some color blind safe palettes available for us. So this person, Cynthia Brewer, created these palettes for color blind safe palettes. So you just need to install this package called R Color Brewer. There are three groups of colors. First one is sequential. So the ordering of the data has only one direction. So basically, in this palette, for each color palette, there is only one color, almost one. Okay? Maybe it's gradually change a little bit. Okay? So it's good to show continuous numerical variables or discrete numeric variables, okay? As long as it's kind of there is an ordering, there is an order among the numbers. So sequential, good for quantitative data. And the second group is a qualitative group. So see set 1, set 2, set 3. So see there is no continuity between the colors next to each other. That is because these color palettes are good for categorical variables. Right? The purpose is to show contrast, to compare different categories. Right? So the more difference, the better. So that's why they are not continuous. Right? And the last palette, the last group is diverging palettes. So they are good to show the ordering of data has when data has two directions. For example, the presidential election data, you can use red to represent Republican and blue to represent Democratic. And then you can allow overlapping areas, which will be purple, okay? But in this case, the middle area, the battleground will be shown as like white, okay, somehow. But anyway, is diverging to do two directions. Um, so these are all available for us as long as we install this package, our color bluer. Okay? Very pretty colors, and they are colorblind safe, which is really good. And we talked about a lot of visual cues. So which ones are more effective, which ones are less effective. So we actually have compared length, area, and volume already. They are in this order. If we have to put them all together, then position is the most effective, and color hue is the least effective. But of course, this comparison is not a very fair comparison because some color hues are for categorical variables, some are for numerical variables, some are used for two variables, right? Some are used for one variables. So not a very fair comparison, but this is just um, a rough ordering, okay? And this also shows you the effectiveness of color hue, visual hues. The first column uh, lists the visual cues for magnitude channels or ordered attributes. So if your data is quantitative or categorical but ordered, okay, ordinal data, then you can use these visual cues. So still, position is the most effective, and then position on unaligned scale, then length, angle, area, depth. Depth is the third dimension. So it's demonstrate the volume actually. And then color luminance or color saturation. And then, yeah. Anyway, so sometimes people use different terms on the same thing. And curvature and volume. And for categorical attributes, the most efficient one is spatial region, and then color hue, etc. We just need to have an idea about the relative effectiveness of these visual cues. We don't have to be very rigid. We have to pick the most effective one. Always, we don't have to do so. We can be very flexible. All right. We're done with the first element, visual cues. Then the second element is coordinate systems. So roughly speaking, there are three coordinate systems: the Cartesian system, polar system, and geographic system, map system. For Cartesian system, we have two coordinates, x and y. So this one is a Cartesian system. And for any observation, you need to specify two coordinates. And in the polar system, we also need two coordinates, but they are r and theta. R is the radius, and theta is the angle. So for example, for any points in the polar system, we use two numbers to denote it. One is r, the other is theta. R is the radius, and theta is the angle. So there is a one-to-one correspondence between a point in the Cartesian system and a point in the polar system if both variables are quantitative. But sometimes, pay attention, you may use categorical variables in a Cartesian system. It's okay, it's totally fine. Right? Or even, usually one categorical variable. For example, in a bar graph, the x variable most likely is a categorical variable. The y variable may be a numerical variable. And last one is geographic system. The coordinates are the latitude and the longitude. So usually it is just for creating maps Uh, so because a map is a two-dimensional projection of a three-dimensional object. Our Earth is a ball. If you force to project it to a two-dimensional plane, then there must be some kind of distortion. So a geometric coordinate system will try to minimize this kind of distortion or complement this kind of distortion so that it will reflect the true look of the earth, the surface of the earth. Okay, so that's why whenever you draw a map, try to use a geometric system instead of a flat Cartesian system. All right, next element is scale. So scales translate values into visual cues, and the choice is often very crucial. So we will briefly introduce a few scales that we commonly use in data science. The first one is numeric. So this is the most commonly used one. So it's used to measure numeric variables. There are different types of numeric scales. Linear is the most common one. And then we also have logarithmic, percentage, etc. And time is also a numeric quantity, but it has some special properties. So first of all, because of the calendar, it can be separated by a series of different units. For example, year, month, day, hour, minute, second, even smaller units. And secondly, it can be considered periodically as a wraparound scale. It's just like a clock. It repeats itself. It's periodic. So time is a special numeric scale, but because it's very special, we just call it a time scale. And then last one is categorical scale. For categorical variables, we need to use categorical scales. And there are two types of categorical variables, right? We have nominal categorical variables, and we also have ordinal categorical variables. For nominal categorical variables, there is no intrinsic order among the categories. So in this case, it doesn't matter how you order the categories on the axis. It doesn't matter. But for ordinal, for example, you have a variable which is used to measure the smoking status. There are three levels: never, former, and current smoker. Right? So apparently, in terms of the influence on a person's health situation, these three categories are ordered. And never, maybe no influence, definitely no influence, and former, potentially some influence, and current smoker, ongoing influence. So clearly these three levels are ordered. So that's why it's called ordinal data, ordinal variable. In this case, you need to order them in the correct order when you put the values in the axis, in one axis of the graphical display. Okay. All right, let's take a look at them in more details. So scale. So this part shows you 6 commonly used scales. Linear. In a linear system, so the increase of the values are linear, 0, 1, 2, 3, 4, right? And then logarithmic. So this one is also a numeric scale, but instead of increasing the values linearly, the values are increased exponentially. So notice that 0 is what? 1 is 10 to the 0. 10 is 10 to the 1. 100 is 10 squared, etc. So the values are increased exponentially. And logarithmic scales are good for data with a lot of outliers on the right-hand side of the coordinate system. For example, if the data looks like this, right-skewed, a lot of outliers on the right, then it makes sense to use logarithmic scale because if you take log of some positive values, then small values, relatively small values, values between 0 and 1, will be exaggerated in terms of magnitude, although they will be transformed to negative values, like log x. If x is less than 1, it will be negative, but the magnitude will be enlarged. Okay, but for big values, like somewhere here, if you take log, they will be compressed to smaller magnitudes, smaller regions. So consequently, overall, it will be less skewed if you take log of your data. Similarly, if you use a logarithmic scale, the data will look like more, it will be less skewed and more symmetric. And so this one is numeric, logarithmic is numeric, and also percent is numeric. By the way, logarithmic scale is commonly used earthquake strength, sound loudness, light intensity, pH of solution, etc. As long as the data is just right skewed, with a lot of outliers on the right-hand side, it's good to use logarithmic scale. And the data itself should be positive. Otherwise, you cannot use log scale. And then categorical scales, categorical and ordinal. So if there are no intrinsic order, you use a regular categorical scale. If there are intrinsic order, for example, small, larger. So see horrible, bad, okay, good, great. They are. There is an ordering among the categories, then you should put them in order. And then last one is time. January, February. So this is corresponding to months. You should order them according to the time order instead of following the alphabetic order, right? And also this part shows you the periodic feature of time. Time in a day, week, days of a week, and months, and then seasons, right? So all of these are time scales. And finally, this one shows you a bar graph. So in a graphical display, you can use different scales on different axes. You don't have to use the same scale on all the axes, of course. It's quite flexible. All right, the next slide shows you the importance of choosing an appropriate scale. So all of these 6 maps or graphs are using the same data set. Roughly speaking, the same data set. But if you manipulate the data or you transform the data differently, you will see completely different graphs, right? So the first one you see, it uses quartiles. So the variable is percent with at least bachelor's degree in 2009 percent. So the unit in the data set is a state, apparently, including DC, I think. So 51 units, 51 observations. And then it actually cut the variable into 4 categories using the quartiles of data. So Q1, the median, and Q3. So Q1, by definition, is the value such that 25% observations are less than or equal to Q1, the value, right? And then median is the midpoint. Right? And Q3, 75% of observations are below this final or the maximum. Okay, so totally, so the data is categorized into 4 small intervals and then use different color saturations to demonstrate the 4 categories. So this is important. And this one is linear. They just use 15%, 20%, 25% as threshold. And this one only measure the mean. So see, if you use different standard, different scale, you can see different, totally different graphs. All right, last one is context. So a visualization is not only about the look of the plot or graph. It's necessary to add some context so that when people look at your plot, they understand what information you want to convey. Right? Titles, subtitles, very important. Captions, sometimes important. For example, usually you provide data source in the caption part, and then axis labels, very important. Right? Your readers need to know what these 2 axes are about. Right? And the last one, reference points or lines. So this is also important. Right? So very likely you will your plot will display grouped data. Then you need to provide a legend. You let people know which line is for group A, which line is for group B, for example. Right? So also very important. So these are items in context. Put them together, you see so different visual cues in different coordinate system can create different plots. For example, length. In a Cartesian system, it could be a bar graph or a histogram. You can also put it in the polar system and create a plot like this. I don't know what is the name of the plot, but I have seen this before. But to be honest, this is not a very effective way, right? Because it's difficult to compare a bar here and a bar here, right? They are not next to each other. And in a map, geographic system, length can be used to measure the distance. For example, the distance of a route, of an airline, of a flight. So a lot of possibilities. And the last slide is dissecting a plot. So given a plot, you should be able to dissect it. Namely, you decompose it into the 4 basic elements. So this is a way to train yourself to truly understand a graphical display. For example, this is a bar graph, not a histogram. It's a bar graph. So each bar is corresponding to a month. So let's start from the beginning. Which visual cues are used in this plot? So apparently length is used. And color is not important because all the bars have the same color. They use the same color. So color hue is not a visual cue. And coordinate system, apparently this is a Cartesian system. Right? And scale, the X variable uses a time scale. The Y variable uses a linear numeric scale. You see numbers, units are increased linearly. And lastly, context. Let's identify the context provided. There is a title, a subtitle, and a caption, And there are no X and Y axis labels, but there are tick marks for in the X-axis and Y-axis, and also the units. So that's all. That's all. But I think it's enough. You don't have to add the axis label. For example, it's apparently time. You don't have to put months here. All right. And there are a few exercises at the end of the lecture, but we will skip them as usual. I hope that we can finish the first part of ggplot2 and then next time so that we have enough time for you to have a quiz on Thursday. All right. Do you have any questions? All right. So now let's move on to ggplot2, implementing the grammar of graphics using ggplot2. I suspect GG stands for grammar of graphics. Okay. All right. First, let's see packages that we will use in creating graphs, for creating graphs. So in our class, we actually will use many packages. The first package is called MDSR. It's Modern Data Science with R. This is the package associated with our textbook, the first textbook. So it's free. You can download and install it by yourself. It has some data sets that we will use in the future, in next module, and also this module. And tidyverse. So this is a package, and it is also a collection of packages. It contains most of the packages that we will use in our class. So if you click this link, you will be directed to this page. This is the web page for tidyverse. It contains a lot of packages, and among them, there are 9 core packages: dplyr, ggplot2, readr, etc. ggplot2 is used for visualization, dplyr is used for data wrangling, etc. And if you click packages, then you will be directed to here. So this one lists this web page shows you all the packages that are included in tidyverse. So there are 9 core packages, as I said. Core packages will be loaded whenever you load the tidyverse package. So they will be available for you. But there are some additional packages that are included in tidyverse. So as long as you install tidyverse, they are installed at the same time. But when you load tidyverse, those packages won't be loaded automatically for you. Those non-core packages. So let's take a look at the core packages. ggplot2 is the first one, and dplyr is used for data manipulation. tidyr is used to clean data, like change the format of data sets. readr contains some fast and friendly way of fast and effective functions to load data, to read data. And purr is used to work with functions and vectors in a consistent and fast way. And tibble, string R. And the last one is used to deal with time, dates, etc. Lubricate. But in this module, we will focus on ggplot2. So I encourage you to install tidyverse directly so that all of these will be available for us to use. We will use almost all of them in our class. Go back to our lecture. So ggplot2 and dplyr are part of tidyverse. And then there is also a package called Mosaic. So this one has some data sets that we will use. Now let's focus on ggplot2. So this a package this is a package which implements the grammar of graphics. So basically, it considers the four elements of graphics: visual cues, coordinate systems, scale, and context. Okay. And a very helpful tool is the visualization cheat sheet. If you click this link, you'll be directed to somewhere here. The POSIX webpage about cheat sheets. I've shown you how to find the cheat sheet for our knockdown. For now, ggplot2. Click view the cheat sheet. You'll see the cheat sheet webpage. So if you want to download it, just click this one. You will download this PDF version of it. Otherwise, you can just read the web page. Everything is enlarged. It's easier to explore to read because the letters are larger. Okay. All right, let's go back. So now so because this is the first class about ggplot2, I will explain everything in details. It seems very slow, but I think it's good to start in the right way so that you can avoid a lot of errors in the future. Right? So we will follow examples in our second textbook, R for Data Science, the free book. And we will use a data set called MPG. So this one contains observations collected by the U.S. Environment Protection Agency on 38 models of car. So it's a very small data set called MPG, only 38 observations. So MPG is actually a table. Okay? A table is a special format of data frame. So let's first load the Mosaic package. I think MPG is built in Mosaic. Right? So I load the package and then check the class of MPG. This is a data set. Right? So there are three strings: table, df, table, and data.frame. So it is a data frame, but it is not only a data frame, it's a table. We will focus on tables a little later, but for now, you can treat it as a data frame, a two-dimensional data set. Let's first check the dimension of MPG, 234 rows and 11 columns. All right, sorry. I said 38 observations. That's not right because each model may have multiple cars and multiple rows about it. So totally 234 rows. Take a look at the first three rows of the data set. So I chose to print the first 6 columns and then the last 5 columns separately. That is because MPG is a table. And by default, if you print a table, it will only show the columns that can fit into the current screen, no matter how big it is. For example, because I generated a slide presentation, I separated into 2 parts. So this is narrow, and then it will only show a few columns. So that's why I separate. I use 2 head functions to show them separately. Let's take a look at the variables in the data set. Manufacturer of the car, model, displacement. So this one is engine displacement measured in liters. So this one is used to measure the size of the engine. And then year of manufacturer, cylinder is the number of cylinders, and type of transmission and type of drive, front wheel drive, rear wheel drive, and 4-wheel drive, right? 3 types, the categorical variable. And then city. So this is the city miles per gallon. apparently this is one of the response variables that is of interest. It's used to measure the fuel efficiency of a car. And we have a similar response variable called highway miles per gallon. So this is another measure of the efficiency. So we have two options. Right? We can also take average of them. But anyway, they are all available for us. And then fuel type and lastly, type of car. You see compact or minivan, etc. All right. Now, suppose we want to answer a question, a research question or a hypothesis. Do cars with big engines use more fuel than cars with small engines? Basically, we want to know if cars with big engines are less fuel efficient. Based on our common sense, it should be the case. The larger the car, the less efficient it is. We want to answer this question using a visualization only. So let's create a scatter plot to show the relationship between engine size and fuel efficiency. Of course, we have two options for the measure of fuel efficiency. We have city and highway. Suppose we just choose highway MPG. And X variable has to be this displacement. So this is the only one that we use to measure the engine size. Okay? And let's create a scatter plot. So we first load the package. As I said, if we load the tidyverse package, then all of the core packages will be loaded automatically, including ggplot2. If you don't want to load the gigantic package tidyverse, for now, you can just load ggplot2 directly. Let's put it here, ggplot2. And then let's see how to create the plot. So start with the ggplot function, parentheses specify the data set, plus gm point. And then there is a mapping argument. X is equal to displacement, Y is equal to highway. Right? So let's first take a look at the plot. Apparently, there is indeed a negative relationship between displacement and highway efficiency, which is expected. And then let's zoom in the code. So with ggplot2, you begin the plot with a function ggplot. So you always start with ggplot. Right? And then the ggplot function will create the coordinate system. So basically, it will not do anything else but create a coordinate system. By default, it is a Cartesian system. Right? Unless you change it at the end, you have the option to change it later, but by default, it's Cartesian system. And then the first argument and a necessary argument in ggplot is the data argument. You need to specify the data set you use to create the plot. Right? We use MPG. And then after this part, you have the option to add layers of visual cues to it. Okay, so that's why there is a plus here. So that means we are adding a layer of points into the Cartesian system, right? Coordinate system. So that's why you always connect with a plus. And gm point is used to add a layer of points. Right? GM stands for geometric object. GM points is used to create a scatter plot because it will add points to it. So yeah, GM stands for geometric objects, and ggplot2 provides a lot of options for geometric objects. For example, GM smooth will add a smooth curve. like lowest local weighted regression curve to it to the system, and GM bar will add bars to a system, right? And GM polygon will add polygon histogram polygon to a plot, frequency polygon to a plot, right? And ggplot2 allows you to add multiple layers of visual cues into the same system. So namely, after you add a layer of point, you can continue plus, and then, for example, gem smooth, you can add a layer of a smooth curve to the point to show the pattern, right? So it's very flexible. This is the basic syntax of the ggplot function. Data equals some data set and plus, right? And some GM function. It depends on what visual cue you want to add to the system. You can choose a GM function. We use GM point. And then within the GM function, there must be a mapping argument, So this mapping argument is used to map your data to actual visual cues. In our previous example, you see we map displacement to the x-axis and highway to the y-axis. So namely, we map these two variables into the position of points. Okay? And notice that in the mapping argument, you have to wrap everything in AES, in the AES expression. AES stands for aesthetic. So basically, it's you use it to wrap all of the different pairs of mappings in it. And you have to start with it. You can omit this mapping equal to, actually, because this is the argument name. You can omit it. You can start with AES, but this AES cannot be omitted. Right? And so in the syntax, we actually can identify the four elements in graphical display. First, ggplot2, the ggplot function will open a coordinate system, right? And visual cue is used, visual cues are specified in the mapping part, right? And then scale is automatically chosen as appropriate as possible. So basically, there is a default scale for each coordinate system. So if you use a Cartesian system, and also of course it depends on how you map the x and y variables. Okay, so it will automatically choose an appropriate scale for you. And context is given by the axis labels. So by default, it will provide some context, but minimally. Basically, x and y axis labels will be provided, and no title, no subtitle automatically created for you. You need to add them by yourselves. And then let's add more. We can add more variables via visual cues. So from this plot, you see that there is a kind of linear, but not exactly linear pattern, right? So if you carefully examine it, you see that there is a kind of a curly relationship, right? So this part does not follow the pattern that well. Okay? So they are kind of like outliers. So in this case, you might suspect that some categorical variable plays a role in the relationship between displacement and highway efficiency. Right? So in this case, you can choose to map the categorical variable into a visual cue, for example, color or shape of points. So let's map class to color. So notice that I just add this argument within this AES expression because it is a mapping, right? It involves variables. So it's a mapping. We map class to color. So it has to be in the mapping. So if we do so, we quickly identify that these points all belong to one class, which is two-seaters. Which is intuitive because sports cars are usually have large engines because they are very fast, but at the same time, they are not so efficient. Right? So they are better than other large cars like minivans or else, but it is so they are kind of a special group. Right? So this one, so by mapping class to color, we figure out the reason. Right? So these are special. Now let's zoom in and talk about more details in the mapping and more options. For example, we can change the shape of the point. For example, we can choose, let shape be 22. 22 is a point like this. It's an empty square. Okay. And in this case, if we want to map class to color, we should let fill be class because we will actually specify the filling color of the point, shape 22, right? Specified by fill. Right? If you use color, then the boundary of the point will be changed, but the inner part is still empty, it's white, right? It's transparent. So it really depends on the type of point you use. But by default, it is a solid round point. You can map class to color in that case. For solid points, you can map class to color. And notice that shape equals 22 is outside of AES. Okay. What's the difference between shape equals 22 and these three arguments? Can you tell?
Is it because shape is not referring to a variable in the data set?
Exactly. Thank you. That's correct. Right. So this one does not involve any variable. It's not mapping. It's not a mapping, right? So it should be outside of this AES expression, right? And it's a kind of a constant. You assign a constant value to an argument. It should be outside of the mapping argument. Great. And because we understand that, then we have more flexibility. For example, if we don't want to map class to color, we can just use the same type of points with this in the same color. Then we can, for example, specify shape equals 15. Then it's a solid point. Right? Shape is 15 solid point. And that color be blue. So again, this one is still mapping, changing color, but it does not include any mapping of variables. So it should be outside of AES, right? And size is used to control the size of the point. So this is just another example. And in our class, of course, we cannot demonstrate all of the possibilities in colors and other things, shapes. You can take a look at this website for different choices of colors. And also the our color brewer package has a lot of colors available for colorblind safe palettes we just talked about. So for each color, there are different ways to identify them or to define them. Right? There are hexagon code, like name code, number code, different things. And our last topic is adding more variables via facets. sometimes you think a categorical variable is very useful in explaining, in influencing the relationship between some other variables. In that case, you can choose to create subplots or facets according to the categories of a categorical variable. So this is one option. So previously we mapped the class variable to color. So that is one option. The points are all together. Okay. However, if they overlap with each other a lot, it will be difficult to identify the pattern, especially if there are so many classes, so many categories. They all mix together. Okay. If you want to separate them, you can use facet. So ggplot2 provides two functions. The first one is facet wrap. If there is only one categorical variable that you want to add to create a subplot, we use facet wrap. So you can just add this facet wrap function at the end of your plot. So for to avoid repetitions, I first create a scatter plot, a very basic scatter plot with displacement and highway, the black point one. I call it G, assign it to G. Okay. And then I can take G and plus facet wrap to that class. So the grammar, the syntax is always like this. Okay. Tilde your variable. That means I will create subplots corresponding to the categories of the variable to the X. So this is kind of like a formula. And you can optionally specify how many rows you want. If you don't specify it, the ggplot2 will choose the number of rows for you. Okay. Let's see. So this is the result. G is the original scatter plot, and we add facet wrap. So let's see for different classes. For each class, we have a small scatter plot. And the very good property is all of the facets share the same X and Y, X and Y axis labels, and also the tick marks. They are all shared with each other. So yeah, avoid repetitions. So then you can see the relationship between displacement and highway are kind of different for different classes of cars. For two-seaters, for example, almost no relationship. If you fit a regression line, probably it's horizontal, right? And for compact, you can observe the biggest slope, the negative slope, and mid-size minivan. So you can observe that there are different kind of relationship between X and Y for different classes, which means the class is indeed a very important factor in influencing the relationship. And if you have two variables, two categorical variables to group the data, then you can use facet grade. So the only argument you need is a formula in it. For example, a drive to the cylinder. So this means the rows are corresponding to categories of drive, and the columns of the entire plot are corresponding to the categories of cylinder. Cylinder has four categories, 4, 5, 6, and 8, and drive has 3. 4 wheel, front wheel, and rear. And then you have a grid of flats or facets. So some panels are empty because we only have 234 observations, a very small data set. Some of them don't have any observations. So this is an option. You can use facet grade to group the data using two categorical variables. You can also use facet grade for one categorical variable only. You just use this kind of syntax. Suppose you want to facet the plot into columns only, then to the drive, put a period at the beginning. So this means no row variable, we only use a column variable. Alternatively, you can specify the row variable and omit the column variable. Then you will have a column of plots. It really depends on the shape that you prefer, right? Or the space that you have in your report or project or paper, change the shape of it. And lastly, you can also map a variable to color. So it's very flexible. You can add more variables into your plot. But usually we don't recommend you to add too many variables into a particular just one plot, because you want people to focus on the main information, the most important information, instead of being distracted by some trivial information, right? It better just focus on a few things. As long as you can tell the story, that would be good. And another thing I want to emphasize is that the mapping argument can be moved to the ggplot part too. So in this class, we haven't talked about that yet because we only have one layer of visual cues. If we have multiple layers of visual cues, for example, a scatter plot, and then you overlay a linear regression line, right? Apparently, the points and the line share the same X and Y mappings, right? Same thing. In this case, you can move this mapping part into this ggplot function part. Just remember you need to separate arguments by comma. So data, MPG, comma, mapping, blah, blah. So as long as you are sure that the two layers of visual cues share the same mapping, then you can put it in the ggplot part. In that case, this mapping will be a global mapping option for all of the layers after that, after all of the layers in the coordinate system. Okay. However, it doesn't mean that you cannot change it later. It's very flexible. Global options are available, and it defines all of the general options for all of the layers. However, in a particular layer, you can change it. You can add a local mapping argument, and it will override the global option, right? So the global option is the weakest, actually. Okay, it can be overwritten by local options. Okay? So it's quite flexible. And next time, we will see more examples or possibilities, more cases. All right. Any questions? Questions so far? All right. If you have no questions, I will see you tomorrow, where we'll continue to talk about just part two. Okay. All right. See you guys tomorrow. Bye.